Alright, welcome back to our first video using the inequality stuff that we introduced in the Introduction Inequalities video. So with section 3.4, we're going to look at is solving inequalities using addition and subtraction. And it's really important that we open up by focusing on understanding this idea of the addition and subtraction properties of inequality. So the way I want you to think about it is just like it says there. Use the same properties and rules and processes for solving equations as you would with inequalities. So the first one says, okay, if I made the statement that A is bigger than B or A is greater than B, then if I added something to one side, so I add C to one side, just like with equations, I need to do that exact same thing to the other side if I'm adding. And I can see if I'm subtracting, so from B on the right hand side of the original inequality of A is greater than B, that if I subtract C from the right hand side, it's important that I subtract C from the left hand side. And in the same way, if I have the original inequality A is less than B here, it's important that if I add C to one side, just like before with the other inequality, we add C to the other side. It's really important, just like with equations, that we keep that equality or we keep things balanced on both sides. And in the same way, if I take C away from B, it's important I subtract C from both sides. So remember, on the bottom there's that reminder, I can't stress enough, always add and subtract on both sides the exact same thing. Okay, so real quick, let's do a couple problems and get you off to bed and then class tomorrow. So I start out my first inequality. N plus 7 is greater than 3. Remember, our goal here is to find the set of numbers that n could be, because it could be a lot of different numbers. So in order to do that, I see my goal, just like it was with equations, is I want to get n by itself. So I start out and say, okay, great. Then I'm going to subtract 7 from both sides. And remember, just like before with equations, even though there's not an equal sign, there's still that idea that the inequality sign divides the statement into two different sides, the left side and the right side. So after I've subtracted that, on the left-hand side, I'm left with n. My inequality sign stays exactly the same, and on the right-hand side, 3 take away 7 would leave us with negative 4. So now what we need to do is we need to communicate the solution. So if my inequality is right here, it's important that we identify that our solution in this case is that n could be any number greater than negative 4. And you can see how I wrote that solution there. So notice our solution is not actually a specific number, but just like before we said that it was a set of numbers. That a solution set is going to be any number. So now what we want to do is we want to actually to fully communicate our solution. We want to graph it and we actually want to prove it as well. So what we want to do is we want to do a number line. And you can see my number line there. And notice it's not perfect, but the whole idea is that our scaling, that the slashes are each a similar distance apart, that they're clearly labeled. And it's really crucial that we include the starting point, which in this case would be negative 4, and along with the starting point that we also incorporate values that are going to be part of that solution set. So if we know it's any value bigger than negative 4 or greater than negative 4, notice that I included a bunch of values that were bigger than negative 4. So negative 4, I'd go there, just like we talked about, since it's just greater than, we'd put just an open circle, that it's not counting the starting point, and then we're going to, and you can see that we're going to shade everything to the right of negative 4. Now, in order to do our proof, we want to write down the original inequality. So that's n plus 7 is greater than 3. Don't get caught writing down this one, because remember, that's our solution. Just like when we solve equations, we always have to go back to the original statement. So our original statement is n plus 7 is greater than 3. So now we come in here, we substitute in our solution. So we substitute in, and remember that we're going to substitute in a value that is somewhere in the shaded area. So I look and I'm like, well, not a big fan of negative numbers, so I'm going to pick my favorite one to pick, which is 0. So we are going to substitute in 0, and 0 plus 7 would give me 7. 7 is greater than 3. Think about it for a second, say, sure, that's true. Then I know that I shaded in the correct direction. So that means I shaded correct, which means that my solution is great. So please remember that you're picking a point out of that shaded area, not picking the point that you start with. So now as we look at our next inequality down here in the second half of things, it reads negative 6 is less than or equal to x minus 9. Now notice the variables on the right hand side, we're not really concerned with that, but if I wanted to right away, I could flip everything around. But we'll wait and do that at the end. So here, just like before, my focus on this is it's really important that I want to get x by itself, and keep in mind that there is that line down the middle here. So with that in mind, I say, okay, well, to get x alone, I need to add 9 to both sides. So I'd add 9 to both sides. Negative 6 plus 9 would leave me with 3. Less than or equal to sign stays the same, x is on the right. Now, just like before, remember I talked about, I don't really care for the fact that x is on the right-hand side, because when I read it, when I graph it, when I think about all those different rules of inequalities we're making, it's important that there's consistency. And that consistency here is going to be having the variable on the left. So we're going to switch it around. So write x on the left, write the 3 on the right, and once I've done that, the only thing I need to remember to take with it is that if up here, the alligator is eating the x, that it needs to be eating it on the final answer as well. So there's my solution, and the way I'd communicate that solution in this case is if it reads x is greater than or equal to 3, that we remind ourselves that's going to be any number that's greater than or equal to 3. So again, we're going to go ahead and we're going to draw a number line, and just like before, we have our number line scaled, and so we're going to go to 3. And we look here at the inequality sign, and I can see with the inequality sign that it's greater than or equal to. So at 3, that means I put a closed circle for the or equal to. Then I ask myself, if I'm at 3, which direction are the values greater? And I know the values are greater to my right. So I shade to the right, put my big arrow to remind me it keeps going. And then the last part of things is that we prove our answer. So we write down the original inequality. Negative 6 is less than or equal to x minus 9. And please remember, you write down the original one, and then we're going to substitute in for x. So in place of x, we're going to pick, and let's pick 5. That sounds easy enough. So we put in 5, and then we go through and we just evaluate both expressions, or simplify both sides. So left-hand side, simplified. Right-hand side, 5 take away 9 is going to leave me with negative 4. And then I just ask myself the final question, which is this. Is negative 6 less than or equal to negative 4? And I say, yeah, it's less than. So I know at that point, sure thing, I did it correctly, and I am right. Now, the thing, again, I really want to stress is remember that you don't ever want to pick the starting point to check your answer, because the starting point will always prove you right, but that doesn't tell you shaded in the right direction. So make sure that you pick your final checking point from the shaded area. All right, let's look at one more problem here. And just a reminder that when you're checking your solution of inequality, please pick the value from the shaded region. Cannot stress that enough. All right, so let's take a look at this one. 10 is greater than or equal to y plus 4. Notice I took away all the structure of stuff, so this is kind of like how a homework problem would look. Let's go through and do this together real quick. So 10 is greater than or equal to y plus 4. I want to get y alone, so I'm going to subtract 4 from both sides. And I would get 6 is greater than or equal to y. But then I want to flip it around, so I flip the y and I flip the 6. So it's important that we also flip that inequality sign. So again, notice the inequality sign from here to here. If I flip the y and the 6, I also flip that. So my solution in this case would be described as any number that is less than or equal to the number 6. And we want to graph our solution always. So we draw our number line, we put some slashes in there, and you'll notice that I'm a big fan of making sure that if I do the 6 here, because I know it's going to be less, so I'm going to be going to the left. So I will typically think kind of through that idea when I do my scaling. And so there's my number line, scaled it, and then I graph it. So I first ask myself, is it open or is it closed? So I noticed that I saw that phrase equal to, which means at 6 it's going to be a closed circle because we're counting it. And then less than is going to be to the left. And I always like the slogan, less is left, less is left. So I shade to the left. And then our final part of things, we're going to copy down on our proof. We're going to copy down the original inequality, and we're going to pick a value. So again, I have 0 or 1's an option. I always pick them because they're easy. So let's do 0 again. And when we put in 0, I'm going to put 0 in here, rewrite the rest of the original inequality, and I evaluate or simplify both sides. Left-hand side, it's simplified. Right hand side, 0 plus 4 is 4. And then I ask myself that question, is it true? Is 10 greater than or equal to 4? And I say, sure thing, it is greater. So, and notice again that we did not pick that starting point. Never, never, never pick your starting point to check your solution. All right, so kind of the 4 steps that you go through to solve an inequality. Make sure these make it into your notes. And here they go. The first one is that when you solve an inequality, remember that you follow the rules of equality, keeping the sides balanced, and also doing inverse operations. Remember, that's the idea. If you add to one side, add to the other. The second one is always asking yourself the question, is it open or is it closed? And remember that it's open if it's only greater or less, and it's closed if it's equal to. And which direction do I shade? Well, remember, less is left, greater is right. And finally, check your solution by always picking a point to prove that your inequality is complete. And where does that point come from? Remember, it's only the shaded region. Never ever pick that starting point. All right, so there's your notes for 3.4. Please go back and really look over that process, especially on the last slide where we did the whole problem, like a homework problem together. Look forward to seeing you in class and working with these tomorrow.